Now that we've learnt about loops, it's an excellent opportunity for us to learn about arrays, because arrays and loops often go hand in hand. So, what is an array? Well, an array is a variable. That's the first thing you need to know. It's a special type of variable. It's a variable that represents a collection of identical objects. In other words, it might be a collection of integers, or it might be a collection of floats, or a collection of chars. We think of an array of characters, or an array of integers. There can be as few as one element of the array. You can have an array of one integer if you want to, which is a little bit silly because you could just declare an integer instead, but it is possible. How big can an array be? Well, that depends on the memory architecture of your system, but theoretically as much as memory will allow. In other words, you could have 100,000 elements of your array. You could have 100 million elements of your array. It just depends on your computer. So, is this an entirely new concept, or have we already seen arrays before? Well, we have kind of had a brief look at an array before. We saw an example of a string. Now, remember, if you will, that strings were arrays of characters. That's not all a string was, though. A string was an array of characters that was terminated by a null character. It's important to remember that. If it wasn't for this null terminating character, then a string would simply be an array of characters, and that's all. Just a bunch of characters, a collection of characters. And it's the null terminating character that turns it into a string for us, a piece of text, something that can be printed and copied and so forth. Recall from our discussion on strings that this is how an array is declared, or this is how a string was declared, and I'm going to now extend that to the general case and show you how arrays are declared. Firstly, you have a type name, in other words an integer like int or char or float or double, one of the basic types. It can also be long or unsigned, any of those. Then you have the array name. This is like the string name. This could be anything. This is a name that you invent. This is like my collection, or bunch of apples, or whatever you want to call it. List of boys' names. Anything that makes sense to you. Finally, you have square brackets. Square brackets that surround an integer, a whole number. You cannot put the name of a variable inside the square brackets when you are declaring an array. You can do it when you're referencing an array, when you're using one, but you can't do it when you're declaring one. This is the reason for that. The compiler must know at the time that the program is being compiled how much memory will be set aside for that array when the program is run. So in other words, it has to be a constant. You can put something like 6 plus 7, as long as it is 6 and not a variable that contains a 6. But if you put 6 plus 7, the compiler can figure that out. It goes, okay, well that's really 13. It's got to be something that the compiler can figure out at compile time. It cannot be anything that could be determined at runtime. That's why it's a literal, or something that evaluates to a literal. Okay. Once an array has been declared, you can reference each element separately. For example, if we had an array of floats, in the previous declaration example, the type name might be float, an array name might be float array, and the int literal might be, I don't know, 20, some large number of floats. So then, if we ever needed to assign one of those elements, we could do it like this. Float array square brackets 5 equals 3.56. In other words, we're taking the float value of 3.56 and we're assigning it to the sixth element of the array, to the sixth element. You think, hang on, no, that's wrong. It's got to be the fifth element, right? No, it's actually the sixth element. So why is it the number 5 mean it's the sixth element? Well, I think I referred to this briefly when we talked about strings, but the first element of an array always is the 0 element. Float array 0. Float array square brackets 0 would be the first element of this array, and float array square brackets 1 would be the second element. So of course number 5 would be the sixth element. Okay, let's move on. Loops are excellent for performing operations on all elements sequentially. Loops. Loops are excellent for this. You find arrays and loops used hand in hand all the time. You declare an array of something. You declare an array of 100 integers, or an array of 100 floats, or whatever. Now, you want to perform an operation on each one of those 100 elements. Are you going to write 100 lines of code, one for each element of the array? Do you really want to write 100 almost identical lines of code? Probably not. It's unlikely that you would. It could happen on a very rare occurrence where all the elements of the array are so different that there's no real way of making a common piece of code that could reference each one of them. But what typically happens is that you manipulate the elements of an array inside a loop. And the loop would typically be a for loop, essentially saying for some loop index equals 0 all the way up to the loop index of the number of elements, so incrementing by 1 each time, reference one element of the array and do something with it. Now, remember in that example that I just read out to you, the array element would start with 0 and go up to n-1 for an array of n elements, not going from 1 to n. That's simply the way that C works. It always goes 0 to n-1. If you've come from a language like BASIC or Pascal, then you will find this difficult to get used to at first. It does take some time to adjust to it. But once we start having a look at pointers, and in particular pointer arithmetic, you'll find that the 0 to n-1 way of doing things actually makes a lot more sense than the 1 to n. It may not be more user-friendly from a programmer perspective, but it certainly reflects the system architecture and the actual memory architecture of